The subject of what existed before the enormous detonation has ignited interest and discussion for quite a while. It is a major secret, not just about how we could grasp the universe, yet additionally about the restrictions of human knowledge. Envision standing on the edge of all that is on thinking's mind. What was there before the universe began? The huge explosion marks the beginning of all that we realize: time, space, and matter. But was there something before it? Might there at any point have been a period before this extraordinary event? And if this were true, what was it like? As we explore this question, science takes us on a journey into ideas that challenge what we assume we know. Renowned physicist Brian Cox, who is known for making sense of the marvels of the universe, suggests that something astounding could have existed before the enormous detonation. He prompts us to think about reality and existence. In this discussion, we'll break down the science and ideas that could help us comprehend what preceded everything we know. We'll take a look at theories about quantum changes, dark energy, and even the possibility of multiple universes. The answers could surprise you, and they could fundamentally change the way we understand our place in the universe. Let's dive into a world beyond imagination, where mysteries still puzzle scientists and, at times, leave them questioning everything. Understanding the Big Bang. To comprehend what existed before the huge explosion, we first need to understand what the huge explosion truly was. Scientists say the enormous detonation was the moment when the universe became extraordinarily hot and dense, rapidly expanding and beginning the development of matter and energy. When we look at the stars and galaxies today, we see signs of that hot beginning, as galaxies spread out from a single point. But why did this happen? And was there anything before this hot start? As proposed by the theory of cosmic inflation, before the enormous detonation, the universe was cold, empty, and void. Yet, this emptiness wasn't entirely empty. It contained a vast amount of energy that caused the rapid expansion of space itself. This rapid expansion, called inflation, happened so quickly that it set the stage for everything that came after. As this expansion slowed down, energy transformed into matter and the forces we recognize as the enormous detonation. But where did this energy come from? And why did it suddenly create the universe? The multiverse hypothesis. Some scientists believe that inflation created patches of the universe, each with its own huge explosion, like a cosmic fabric stretching endlessly with bubbles forming here and there, each bubble representing a different universe, including our own. This idea, called the inflationary multiverse, suggests that there could be an infinite number of Big Bangs and universes. Our own universe is just one of many. This incredible idea challenges our perception of the universe and raises the question: what else is out there? Is true nothingness possible? The idea of nothingness before the enormous detonation is speculative, not based on facts. Even if we were to remove all energy, particles, and radiation, the universe would still not be completely empty. Space is filled with dark matter, dark energy, and quantum fields, forces and energies that make up the fabric of everything. Even if we imagine stripping away all these forces, space would still have new forms of energy. This alone is puzzling for scientists, as it suggests that true nothingness might be impossible in our universe. Space itself has properties, rules, and constants that prevent it from being entirely empty. Imagine a region with literally nothing. No particles, no energy, and no radiation. Just quantum fields and constants. These fields would still exist, meaning that even this nothingness has properties. One such property is called zero-point energy, which is the lowest possible energy level of quantum fields. Even at this state, particles can suddenly appear and vanish, creating a strange kind of activity even in what should be empty space. This challenges our concept of nothingness and suggests that even before the enormous detonation, something existed, something scientists are still trying to understand. The eternal inflation theory. One of the most fascinating ideas in modern science is the concept of eternal inflation. If inflation could create our universe, it could continue forever. Brian Cox discusses a vast, eternal inflationary multiverse where universes are constantly being created and expanding. Imagine each huge explosion as a spark that starts a new universe, while inflation continues elsewhere, creating countless other universes. This process could, in theory, go on forever. This idea of new universes giving birth to others is captivating, offering the possibility of a fractal universe where each new universe creates its own huge explosion. Each universe would be separate, unaffected by others, since space is expanding so rapidly. For scientists, this idea is both exciting and unsettling, as it suggests that the universe has no true beginning or end. Imagine our universe as a tiny piece of a much bigger, endless design, constantly expanding and creating new universes. What if, in reality, there is no beginning or end, but rather an eternal cycle of universes being born and dying? Quantum fields and the nature of reality. The way we think about nothing changes when we consider quantum field theory. According to this theory, the universe is not just a collection of matter floating in space. It is a complex network of energy fields that interact to create everything we see. These fields are like invisible oceans, with particles behaving like waves or disturbances. Even when these fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and vanish within these fields, borrowing energy and then returning it. This leads to virtual particles that exist only momentarily before disappearing, leaving behind only a faint trace of their existence. This challenges our idea of true emptiness and suggests that even before the enormous detonation, quantum fields and dark energy may have played a role in shaping the universe. Could dark energy have existed before the Big Bang? Dark energy is a mysterious force that is causing the universe to expand at an accelerating rate. But did dark energy exist before the enormous detonation? Some scientists believe that the dark energy we observe today could be leftover energy from before our universe began. The properties of dark energy suggest a powerful force that may have existed in some form before the Big Bang. Some theories propose that a stronger form of dark energy could have driven the rapid expansion of the early universe. The fact that dark energy exists suggests that, even if all matter and radiation were removed from the universe, this force would continue expanding space. Cyclic cosmology, an endless cycle of universes. Another theory, cyclic cosmology, offers a different perspective on the enormous detonation. Instead of seeing it as a one-time event, it suggests that the universe goes through cosmic cycles of birth, death, and rebirth. In this view, the huge explosion is not the beginning, but part of an eternal cycle where universes expand, collapse, and are reborn. One of the biggest mysteries surrounding the question of what existed before the Big Bang is the nature of time itself. Did time begin with the Big Bang, or did it exist before? In classical physics, time is a continuous and infinite dimension. However, Einstein's theory of general relativity suggests that time is not separate from space. It is woven into the very fabric of the universe, forming what we call space-time. If the Big Bang created space, it may have also created time, but some physicists propose that time might not be linear. Instead of having a single starting point, it could be cyclical or even infinite. In this view, what we perceive as before the Big Bang might simply be another phase of a larger cosmic process. One possible explanation is loop quantum gravity, a theory that suggests that space and time are not continuous but made up of tiny, discrete units, like pixels on a screen. If this is true, then time might not have had a single beginning but could have transitioned from a previous state. The ekpyrotic model, a collision of universes. Another fascinating theory is the ekpyrotic model, which proposes that our universe was born from the collision of two higher-dimensional branes, short for membranes, in a higher-dimensional space. In this model, our universe is not the only one. It exists as a three-dimensional membrane floating in a higher-dimensional space, alongside other parallel universes. Occasionally, these universes might collide, releasing massive amounts of energy and triggering a new Big Bang. If this theory is correct, the Big Bang was not the beginning, but merely one event in an ongoing cycle of cosmic collisions. This idea suggests that before our Big Bang, there was another universe, or perhaps an infinite chain of past universes. Quantum fluctuations. Did the universe emerge from a quantum event? Another possibility is that the universe was created by a quantum fluctuation. According to quantum mechanics, even in the absence of matter and energy, empty space is never truly empty. It is filled with quantum fields that continuously fluctuate, creating brief, temporary particles and energy. Some physicists suggest that a quantum fluctuation in an extremely high-energy state could have given rise to the universe. In this scenario, the universe didn't emerge from nothing in the traditional sense, but rather from a quantum vacuum filled with energy. This theory is supported by the fact that quantum mechanics allows for particles to spontaneously appear and disappear. If tiny particles can pop in and out of existence, perhaps entire universes can as well. Black holes and the birth of universes. One radical idea suggests that our universe may have formed inside a black hole. This idea is based on the fact that black holes contain singularities, points of infinite density where the laws of physics break down. Some physicists, including Nobel Prize-winning scientist Roger Penrose, suggest that singularities in black holes might not just be destructive endpoints, but could also serve as the birthplaces of new universes. In this model, when a massive star collapses into a black hole, the extreme conditions inside the singularity could create a new region of space-time, a baby universe, that expands and evolves separately from its parent universe. If this theory is correct, then every black hole in our universe might be the seed of a new universe, and our own universe could be the result of a black hole that formed in a previous cosmos. The holographic principle. Is the universe an illusion? Another mind-bending theory suggests that the entire universe might be a hologram. The holographic principle proposes that all the information in our three-dimensional universe is actually encoded on a two-dimensional surface at the edge of the cosmos. This idea comes from studies of black holes, which show that all the information about the matter that falls into a black hole is stored on its surface rather than inside. If this principle applies to the entire universe, then our reality might be a projection of information encoded on a higher dimensional surface. If true, this could change how we think about the origin of the universe. Rather than being a singular event, the Big Bang might have been the result of a transformation in a higher dimensional space, with our universe emerging as a lower dimensional projection. The simulation hypothesis. Could our universe be artificial? Finally, some scientists and philosophers have speculated that the universe itself could be a simulation. The simulation hypothesis, popularized by philosopher Nick Bostrom, suggests that advanced civilizations in the far future could create highly realistic simulations of entire universes, populated by conscious beings who do not realize they are inside a simulation. If this were true, then the Big Bang might not have been a natural event, but rather the moment when our simulated universe was booted up. While this idea remains highly speculative, it raises profound questions about the nature of reality and whether our universe has a deeper underlying structure. Conclusion. The quest for answers continues. The question of what existed before the Big Bang remains one of the greatest mysteries in science. While we may never have a definitive answer, the exploration of these ideas pushes the boundaries of our understanding and challenges us to rethink what we know about the universe. From quantum fluctuations to cyclic universes, from the multiverse to the possibility of cosmic simulations, each theory offers a glimpse into a realm of possibilities that stretch beyond our imagination. As scientists continue to investigate gravitational waves, study cosmic background radiation, and develop new theories of quantum gravity, we may one day unlock the secrets of what came before the Big Bang. Until then, the search for answers continues, taking us ever closer to the fundamental nature of reality itself. Uncovered as we keep on pushing the limits of human seeing, yet the inquiry actually stands: what genuinely existed prior to all that? The response might be more abnormal and more fantastic than we at any point envisioned. As we keep on investigating the beginnings of the universe and the conceivable outcomes of what preceded the enormous detonation, Big Bang, we jump further into the realms of speculative science. While certain thoughts challenge the restrictions of our comprehension, others offer us a new point of view on how the universe could have appeared. One thing stays clear: the idea of the universe is loaded with shocks, and the secrets of its beginnings may be considerably more mind-boggling than we can envision. One potential hypothesis is that the universe might have gone through patterns of expansion and contraction, as proposed by the idea of the huge mash, Big Crunch. In this hypothesis, the universe could ultimately implode in on itself, only to detonate in another huge explosion, Big Bang, restarting the cycle. This recurrent model proposes that the universe might have no obvious beginning or end, but rather go on in a cycle of resurrections, where each new cycle is another variant of the universe. As science advances, we could track down replies to these profound inquiries. Yet, for the time being, the mystery of what existed before the enormous detonation will continue to intrigue and inspire curiosity. As we delve further into these secrets, it's crucial to understand that much of the exploration around this idea remains highly speculative. While we can observe the universe's current structure and study its origins through the enormous detonation, what truly happened before this event is still beyond our reach. This does not mean the search is in vain. Rather, the very journey may reveal more about the fabric of reality than we could have ever imagined. One of the most profound aspects of cosmology is the role of time itself. As we know, the enormous detonation represents the dawn of time and space as we understand them. So, the very question of before becomes problematic. According to Einstein's theory of relativity, space and time are not separate entities, but part of a single interconnected fabric known as space-time. This means that asking what happened before the enormous detonation may be futile, as time itself may not have existed prior to the event. If time is tied to the birth of the universe, there may have been little to know before at all. The idea of before the enormous detonation presents another paradox. In a universe where time and space were created in the same event, how can we apply our conventional understanding of past, present, and future? Could it be that time itself is cyclical or not bound to linear progression? This leads us to consider time as a dimension that could stretch and contract, expand and loop without a fixed beginning. Ideas like these challenge human intuition, reminding us that the universe operates according to laws that transcend our everyday experiences and perceptions. In the search for answers, one theory gaining momentum among physicists is the possibility of a quantum fluctuation as the origin of the universe. In quantum mechanics, particles can spontaneously appear and disappear from seemingly nothing, a process known as quantum fluctuations. Could the entire universe have emerged from such a fluctuation in a quantum field? This would suggest that the universe, as we know it, could have arisen from a nothingness that was not truly nothing, but rather a fluctuating quantum field. This view proposes that even before the enormous detonation, there may have been a sort of quantum vacuum, filled with potential energy, yet lacking matter in the form we recognize today. Yet, there are even more unconventional ideas that stretch our understanding. One hypothesis posits that our universe may have originated from a big bounce, a cyclical model where each enormous detonation is a rebirth following the collapse of a previous universe. This model suggests that the universe undergoes an endless series of contractions and expansions, wherein the universe repeatedly collapses under gravity, only to explode again, beginning a new cycle of expansion. In this view, our current universe may have been preceded by another that collapsed into a singularity, only to give birth to the universe we observe today. This theory draws upon ideas from string theory and quantum gravity, yet it also raises questions about what drives these cycles and how they could continue indefinitely. Interestingly, as our observational tools and technology improve, we may one day find indirect evidence that provides more insight into these speculative ideas. Projects like the James Webb Space Telescope are offering astronomers unprecedented views of the universe, capturing light from distant galaxies and revealing clues about the conditions of the early universe. By studying cosmic phenomena, such as cosmic microwave background radiation, thought to be the afterglow of the enormous detonation, scientists hope to gain deeper insights into the earliest moments after the event. In doing so, they may uncover evidence that helps us peer further into the origins of the universe, and even explore what came before. There is also the tantalizing possibility that advanced physics, still in its infancy, will eventually reveal deeper layers of understanding. Theoretical physicists are working on theories that aim to unify quantum mechanics and general relativity, which could allow us to comprehend conditions before the enormous detonation. The theory of quantum gravity, for example, seeks to describe the behavior of space-time at microscopic scales, where both quantum effects and gravity are significant. If successful, these efforts could one day provide a complete picture of the universe's origins and allow us to explore its pre-enormous detonation state. Some ideas even entertain the notion that our universe might not be the only one, suggesting that we are merely one among an infinite number of universes in a larger multiverse. In this view, each universe would have its own set of physical laws, constants, and properties. Our universe, with its particular arrangement of matter and energy, could simply be one of many in an infinitely expanding cosmic structure. This idea also raises the possibility of parallel universes, where events unfold differently from those in our universe. The concept of the multiverse could reshape our understanding of the enormous detonation, suggesting that our universe is just one of countless others that have emerged through similar or entirely different processes. Despite the vast challenges of answering what existed before the enormous detonation, the pursuit of knowledge continues to expand the horizon of human understanding. As scientists continue to explore quantum mechanics, cosmology, and the fundamental forces of nature, the answers to these questions may eventually emerge. Whether we find evidence of a pre-enormous detonation universe, uncover new insights into the nature of reality, or stumble upon entirely new concepts that challenge our understanding, one thing is certain. The mysteries of the universe are vast, and we have only begun to scratch the surface. While the question of what preceded the enormous detonation may never be fully answered in our lifetime, the very pursuit highlights humanity's deepest curiosity, the drive to understand where we come from, what the universe is made of, and what forces govern existence.